Hello everyone. Today we'll be learning an important measure of variation in statistics, and that is called the standard deviation. Okay, so just as a general review, we had the measures of center, and you can think of this as like the summary of the data set. And there were three of these: mean, median, and mode. So while these give you a good summary of the data set, they don't really tell you how spread apart the data is. That's why we're also using measures of variation. And we've done one of them, which is range, which I guess it's the simplest form of measures of variation, and that is just the maximum minus the minimum. But there are limitations to the range. For example, if we have the following, 89, following data set, then 89, 91, 96, 99, and 100. So this is data 1, this is data 2. The two data sets have exactly the same range. Okay, the range is going to be 11 for both of these because they have the same minimum and maximum values. But as you can see, the two data sets are very different. This one has the same numbers, data 1 has the same numbers, except for the last one, the maximum, whereas the data 2 is well spread out throughout. Okay, so that's why we're using another measures of variation, which is the standard deviation. But before we go into standard deviation, I would also like to go through the middle steps of standard deviation. Okay, so what do we mean by standard deviation, and what are the steps that we should take to get to the standard deviation? Okay, so let's focus on the second data set here, since the first data set is not really interesting. Right? It's just 89s and then 100. So let's say that this is a test score for a student throughout the year. And we want to know how well spread this data is. Okay, so instead of just finding the range, which is the maximum minus the minimum, we find the mean deviation. Mean deviation, which means the average difference with the mean. Okay, so by the name of mean deviation, you might assume it has something to do with the mean, and that is correct. So let's first find the mean of this data set. And if you add them all up and divide by 5, you will see that the mean, remember this is how we notate mean. Mean is equal to 95 in this case. Okay, and to find the mean deviation, we're basically finding the difference between the mean and each of this data. So that's the mean. And we're just interested in the difference. So we're actually taking the absolute value of their differences. So if you take the difference of our first data here with the mean and take the absolute value of that, we're going to get 6. This is going to be 4. This is going to be 1. This is going to be 4. And this is going to be 5. Okay, so these are the differences between the data and the mean. And to find the mean deviation, we are finding the average of these differences. So we're doing 6 plus 4 plus 1 plus 4 plus 5. Divide that all by 5. Okay, so let me see. That's 10, 10, 20 divided by 5, right? So that's going to be 4. So the mean deviation equals 4 in this case. And the general formula for mean deviation is going to be n. Okay, so now this looks kind of complicated, but it's really just doing what we just did. So on the numerator here, the x represents each of the data. Okay, so in our case, 89, 91, 96, 99, 100. Okay, the x represents each of the data, and the x bar means the mean, which is 95, and we're subtracting those two numbers. So 89, we subtracted 89 and 95, which was -6, and then we're taking the absolute value of those numbers. That's how we got 6. And basically we do this for all of our data. Okay, that's what we did here, 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 here. Okay, and we add them all up. We added them all up here, and then we divide by how many datas we have. We divide by 5. Okay, so that's what this formula is telling you to do, basically. And that's what we did here. Okay, so that's the mean deviation. But over time, statisticians started to run into problems with mean deviations as well. So they started to develop better forms of calculating the variance, or calculating the variation. So the mean deviation was this, and then this evolved into variance. Okay, mean deviation became variance. It became a more accurate way of measuring measures of variation. And to do this, instead of taking the absolute value, we're taking the square. We're taking the square, and instead of dividing by n, you divide by n minus 1. Okay, now how this formula was derived is a little bit more complicated than can be explained in this video, but I'm just introducing the formula for variance. Okay, so that was the next step after mean deviation of calculating the measures of variation. And because this is actually, so remember for our previous data we had the mean deviation equal to 4, and what that tells us is that the data are about 4 units away, 4 away from the mean. Okay, that's what it's telling us. But when you do the variance, it's actually going to give you the squared number, right? So it's going to give you something close to 16-ish. It's the squared number. Okay, so that's why we get another measure of variation, and this is what's called the standard deviation. And this is what's being used the most among statisticians to find the measures of variation. And what standard deviation is, it's basically just the square root of variance. Square root of sum of all the differences. Okay, so it's basically taking the square root of that to get back into something that looks a little bit like that. Of course, it's not going to be exactly like this, but you're going to get something close to the mean deviation. But in fact, standard deviation is, it gives you a lot more accurate information than what the mean deviation does. Now, I've mentioned before that to notate the mean, we usually use x with a little bar on top. And for variance and standard deviation, they also have special letters associated with them. And that is S, or sometimes they even use sigma. Okay, so variation is S squared and standard deviation is S, because standard deviation is just the square root of the variance. Okay, so that's the relationship between standard deviation and variance. And what this sigma does is that it shows you the difference, or how the data, how the individual data are spread out, how they are different within the data set. Okay, so even though this looks a bit complicated to calculate, it's not that complicated. Oops. So you'll have to find the mean first, and then find the difference between the data and the means, and then square those, and then add them all up, divide by the number of data minus 1, and then take the square root. So I think it's going to be a little bit more easier if you try to find the variance first, and then take the square root of that to find the standard deviation.